Okay, so we did 8.1 and we did 8.2, and that's all of Module 8. There's only 2 sections in it. Module 8 is all about graphing rational equations. Okay, so now we're moving into Module 9, which is now simplifying rational expressions. Okay, and today we're specifically going to talk about adding and subtracting rational expressions. Okay, so by the end of class, you're going to know exactly how to add and subtract rational expressions. At least most of you. Okay, so let's rewind like 6 years ago. 6 years ago, you were sitting in 4th grade, maybe, give or take a few years, I don't know. Sure. And you were learning about adding and subtracting fractions, right? Which technically is adding and subtracting rational expressions, right? Adding and subtracting fractions. And they gave you something like 5/8 plus 1/6. Remember that? Okay, so what'd you do? Okay, so step 1. You can write this down if you want. It's up to you. Step 1. Find the common denominator. I'm going to abbreviate because I'm a math person. You can write whatever you want in your notes. Find the common denominator. Okay, so I'm looking at 8 and 6 and saying, what's the common denominator? Good, 24. Okay, so the smallest number that they both multiply into. Okay, so now, step 2, what do I do next? You what?
So it takes 8 3 times to get up to 24.
Okay.
So you go 3 times 5, which is 15.
Okay, so how can we say that as a step?
Common sense.
Common sense. So you want to write that as a step?
Multiply the numerator by what you used to multiply the denominator?
Or set them equal to each other. It's honestly like a step, but not like equal to each other.
Okay, so what do I have to multiply the 8 by to make it 24? 3. So essentially we're multiplying by the value of 1, right? Because 3 over 3 is actually 1. I'm not changing the value of the expression, just the way it looks. Okay, what do I have to multiply 6 by to make it 24? 4. So I'm multiplying top and bottom by 4. Now what? Okay, so where do I go from here? What am I going to do with this one right here? You multiply it, okay? So we like simplify, so this becomes 15 24ths, right? And then this other one becomes 4 24ths. So maybe we can say rewrite fractions with common denominators. Okay, now what do we do? Okay, add tops. It's way faster than writing numerators. So in our case, what's the tops added together?
19.
So we get 19 24ths. And then we write a happy face. So that's exactly what we're doing today. But we're going to have x's involved. Okay. So the textbook goes through breaking this down like really sequentially, and I think that it's broken down so much that it becomes confusing. So I'm just going to kind of skip to the end where we like just do this, and then maybe we work backwards to what they kind of were hoping for. I hope that doesn't upset you. Guess we'll find out later. Okay, so this question right here, we're adding fractions. So what's my step 1? Find the common denominator. All right. Sounds easy enough. What's my common denominator?
X. Wait, no. This case.
1 plus x? Is that it? Okay, so are you trying to say that x is about the same as 1 plus x? What would you have to multiply x by to make it 1 plus x? Well, you can multiply by something. You can multiply by 1 plus x. Okay, so what you need to understand about this is this number is totally different than this number. These are two different numbers. For example, if I said x is 3, so this is 3, what's this one? 4. So what's the common denominator of 3 and 4? 12. How'd you get there? You multiplied them. Okay, so those are two different things.
Could you simplify that?
Like foil it, is that what you mean?
Yeah, like x squared plus all x.
Oh, no. Do not do that. Okay. So what's my step 2?
Oh, no, it's not accurate.
What?
Like, I just wondered that.
It's her effort of keeping us.
Yeah.
Oh, I see. So you do that. I got you.
It's actually.
So
Well, it's a T.
what's my second step? Okay, I need to make these have the same denominator, right? Okay, so what do I have to multiply 1 plus x by to make it this? X. This one is missing the x, so I have to multiply the top and the bottom by x over x. Okay, so now this one, what's this one missing? The 1 plus x. So I multiply the top and bottom by 1 plus x. Okay, what's my third step? Okay, so simplify each fraction individually, right? Okay, so my left one is going to be 1 over x times 1 plus x. Okay, what am I going to have to do on the right-hand side? Foil, right? Okay, I have to FOIL this. I'm going to simplify it. So what's 1 times 1? 1. What's 1 times x? What's negative x times 1? And what's negative x times x? Negative x squared. What's my bottom? Should be the common denominator, right? Step 4. Okay, add what's together?
The numerator.
The tops. Okay, we're going to add the tops together. Okay, so we're just adding the like terms on the top. Okay, let's start with the biggest exponent we see. We see a x squared. So how many x squareds do I have?
1.
Negative 1. How many x's do I have? 1x. What's my constant? 1. What's my denominator? Okay, so at one point I heard, I think it was Ruby said, do you want to simplify the bottom? Okay, do I want to distribute that through? Okay, you never, ever, 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 ever distribute the bottom. You always want the bottom to be in factored form. Okay, because you can potentially simplify. Okay, now if I did distribute it and instead wrote the answer as negative x squared plus x plus 1 over x plus x squared, would that be a good answer? Yeah, I mean, these two are exactly equivalent, and one is not more simple than the other. Okay, factored form is not simpler than standard form. Okay, but let's not make a mistake by getting there. Okay, so leave your denominators in factored form. Pretty easy?
No, and same, like almost the exact same for subtracting.
Yeah, you just subtract the tops on the last step. Okay, the one thing that we also need to include, okay, so up in the directions it says blah, 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 and then note the excluded values. Okay, so what are excluded values? What are they talking about? Kind of. Okay, excluded values are anything that would make this function undefined. So we're talking about domain restrictions. What are the values that x cannot be? Can't be 0, and it cannot be -1. Okay, so all I'm looking at there is looking at the denominator and saying, okay, it can't be 0 and it can't be 1. -1. Okay, you have to list those along with it. Ready for a second one? Let's do it. Okay, this one is super easy. Maybe I don't even need to do this. Why is this one so easy? Okay, we can go straight to the part where we add the numerators. So, what the heck? What's the top simplify to? -x plus 2. Oh, wait a second. I know why they threw this in here. This one can be simplified. Okay, so remember I just talked about things being in standard form versus factored form? If I factor this, it will be simplified. Okay, on the top, how can I factor that?
Take the negative out.
Take the negative out. I hate it when there's a negative first, so I always pull that away. X minus 2. Okay, what about on the bottom? What does that one factor into?
X plus 2 minus 2.
Good. Okay, so this is a difference of squares. So what can cancel?
X minus 2.
X minus 2. So, tricky question here. What's left over?
-1 over number.
Oh, I'm so glad you guys all said that. I just got done giving an AP test, and you wouldn't believe how many people decided the answer was x plus 2. They did all this hard calculus, and then they got to the very end and said, it's x plus 2, and didn't have the 1 on the top. Whew. So, what are my restrictions? What are the values that x cannot be? Can be -2 or 2. Okay, so you also must include the values that you canceled out because those do exist on the original expressions. Okay, those must be included. Doing good so far? Okay, let's do, whoa. I want a good one, let's see. Ooh, yeah, this is a good one. I like that one. It's not too complicated, but it requires a little finagling at first. Okay, so first step is what? Common denominator. But with this problem, I have a problem. I got a problem. Okay, the bottom right now is written in factored form. I mean standard form. Okay, so the first thing I want to do is if the denominator is factorable, I want to factor it because sometimes it's going to be a lot more simple. So on the bottom, what is the bottom factor for this one?
1.
So x plus 4 and x minus 1. Okay, and what about the denominator on the right one? What two numbers multiply to 2 and add to -3? X minus 2 and x minus 1, good. Okay. I'm going to just slide over here. There we go, because we don't need to look at the original anymore. All right, now let's talk about the common denominator. What's the common denominator? Good. X minus 1. It's part of it. What else? Good. X minus 2 and x plus 4. Okay, so an easy way to think about this is, first of all, I'm going to list what do they have in common. Okay, and in this case, they both have an x plus 1 in common. And then what else do you see? Okay, so I also see an x plus 4 and I see an x minus 2. Does that make sense? Getting there? Okay, so now let's get the common denominator. So what is this left side missing that our common denominator has? An x minus 2. So we're going to multiply top and bottom by x minus 2. Okay, what's the right one missing? X plus 4. What? Is that like a response or just like a... Are you confused?
It's okay. It's okay. Because those two cancel out.
Yeah, but remember we're getting a common denominator. If I went back to that problem where we did 5/8 times or plus 1/3 and we multiplied initially by 3/3, those could cancel out. But we don't cancel it out. The idea is so that we can get a common denominator. Right? Yeah. Okay, what do I do next? Simplify these fractions. So my left one is going to become x minus 2 over that common denominator. Okay, and my right side one is x plus 4. Okay, so now what do I do once I have common denominators? Simplify, so subtract the tops. Okay, so be really careful when simplifying. Remember that this negative has to be distributed through the whole top. Okay, I can almost guarantee there's somebody in here who's going to screw that up. That's simplifying. Don't let it be you. So, how many x's do I have? None, right? They go away. What's my constant? Nice, good. Okay, so we get -6 over x minus 2, x plus 4, x minus 1. That definitely cannot be simplified. Last thing I have to list, what are the values that x cannot be? 2, -4, and 1. How do we feel? Energized? Nope, that's just me.